Webb found a bright galaxy living just 300 million years after the Big Bang. That sounds settled, but the first people who saw it did not trust it. It was too bright, too large, and too close to another source to look clean. So was this really the earliest galaxy ever confirmed, or was the universe playing a trick on the data? Because if this object was real, one quiet red smudge would change the timeline. It would mean the young universe started building big things faster than many models allowed. And once that idea appears, every old assumption around it starts to shake. If you like being with the crowd that waits for the full picture instead of the easy version, subscribe now. This story did not end when the first image came out, and the deeper answer is stranger than the headline. Stick with me, because the final verdict only makes sense when every piece is on the table. To understand why this claim hits so hard, we have to start with the clock. The Big Bang happened about 13.8 billion years ago. So saying 300 million years after means we are looking at the universe when it was barely getting started. That is roughly 2% of its current age, almost the beginning of everything we know. Back then, the universe was not empty, but it was simple. There was mostly hydrogen and helium, the lightest kinds of matter. Stars had only recently begun to turn on, and galaxies were expected to be small, dim, and messy. The first giant cities of stars were supposed to take much longer to appear. That is why the James Webb Space Telescope matters so much here. Webb was built to catch very old light that has been stretched by the growing universe. That stretching shifts light into infrared, which is a kind of light human eyes cannot see. If Hubble could look far back, Webb was built to look even farther. There was also a plan behind the search. One of Webb's big observing programs is called JADES, short for the JWST Advanced Deep Extragalactic Survey. The name sounds heavy, but the idea is simple. Point Webb at a dark patch of sky for a long time and let ancient galaxies rise out of the black. That search was already producing shock after shock. Webb kept finding galaxy candidates from earlier times than many people expected. Some were bright when they should have been faint. Some looked bigger than the common picture allowed. Each new find hinted that the early universe may have grown up faster than our models said. Then one object stepped out from the rest. In early 2023, the JADES team noticed a source that looked even more extreme than the others. It would later be called JADES-GS-Z14-0. The name is not poetic, but the number inside it matters because it points to a possible redshift above 14. That number was so wild that nobody should have trusted it on sight. A redshift is the amount the universe has stretched the light on its way to us. The bigger the number, the farther back in time we are seeing. And a value above 14 would place this object under 300 million years after the Big Bang. But the object did not arrive with a clean, easy story. It looked surprisingly bright for something so early. It also sat close to another galaxy, close enough that the two sources could blur together. If you are trying to make a world record claim, that is exactly the kind of mess you do not want. Now, the easy answer would have been this. Maybe the team was not seeing one super ancient galaxy at all. Maybe they were being fooled by a more ordinary object closer to us. Or maybe the nearby source was making the picture confusing enough to push the estimate in the wrong direction. That is why the next step had to be careful, not dramatic. Images alone can suggest distance, but they do not always lock it down. For something this strange, the team needed a spectrum. That means splitting the light apart like a rainbow and reading it for clues, almost like reading a barcode made of light. Here's the key idea in plain words. Ancient hydrogen leaves a sharp cutoff in a galaxy's light called the Lyman break. As the universe expands, that cutoff gets pushed to redder and redder wavelengths. Find where that drop happens and you get a strong answer about distance. Miss it, and the whole claim can collapse. Before the big test, Webb gathered more hints. In October 2023, the team used narrower filters with Webb's NearCam. That means they took more selective pictures in thinner bands of light. Those new images did not calm the story down. They pushed it harder toward the scary possibility that the galaxy really was that far away. At this point, pause and make your call before the next piece lands. Was Webb about to confirm a record from the dawn of time, or expose a very smart mistake hiding in plain sight? Drop your guess in the comments now, because the answer changed the whole conversation. In January 2024, Webb stared at the source with NearSpec for almost 10 hours. NearSpec is Webb's near-infrared spectrograph, the tool that breaks faint light apart and measures it with real precision. When the spectrum came back, the cutoff was clear. The result was a redshift of 14.32, with enough confidence to make the team stop doubting and start staring. That single number did two things at once. First, it shattered the previous confirmed distance record for a galaxy. Before this, one of Webb's record holders sat at a redshift of 13.2. That older record already felt extreme. Now Webb had moved the line again, deeper into the first few 100 million years of cosmic history. Translate that into normal time and the shock becomes clearer. We are seeing light that left this object about 13.4 billion years ago. The universe was not old, calm, or settled when that light began its trip. It was still in its rough early era. And yet something there had already built a galaxy bright enough for us to spot. Now here is where the story gets even less comfortable. This was not just a tiny point of light with no structure. From the images, the source seemed to stretch across more than 1,600 light-years. That is small compared with a big modern galaxy, yes, but for such an early time, it is not the kind of baby many people expected. The light also looked wrong in another way. If a growing supermassive black hole were doing most of the shining, the picture could be misleading. But the light seemed spread through the galaxy, more like starlight than a single blazing core. That matters because it points toward a real population of stars, and not just a few stars, but enough to suggest a mass of several 100 million suns. That is the moment the claim stopped being only a distance record. A faint ancient object would have been exciting enough. A bright, wide, star-filled object under 300 million years after the Big Bang was something else. It started asking a harder question. How did nature build so much so soon, before the universe had much time to work with? To feel that problem, think about what a galaxy needs. Gas has to fall into dark matter halos, which are invisible clumps of gravity. That gas has to cool. Stars have to form inside it. Then more stars have to form, and enough of them must light up the galaxy strongly enough for Webb to notice from across nearly all of cosmic time. That whole process was supposed to be slower. Not impossible, just slower. Most models expected the first galaxies to be smaller and dimmer at this stage. So when JADES-GS-Z14-0 came in brighter than expected, it did not merely break a record, it pressed against the speed limit many scientists thought the young universe had, and the team still was not done testing it. Webb's mid-infrared instrument, called MIRI, also picked up the source at longer wavelengths. That alone was impressive, because this galaxy was so distant. But the MIRI brightness carried another message. It looked stronger than a simple smooth starlight curve would predict. That extra brightness hinted at glowing gas. More specifically, it hinted at bright emission lines from hydrogen and oxygen. In simple words, certain atoms were lighting up strongly at very exact colors before that light got stretched across space. When those lines show up, they tell us something about the gas inside the galaxy. And what they suggested here was deeply awkward for the old timeline. Oxygen is not there at the start. The early universe began mostly with hydrogen and helium. Heavier elements like oxygen are made inside stars. Those stars then die and throw that material back out into space. So, if oxygen is already present in a galaxy this young, other stars had to live and die before the light we now see ever left. That means the galaxy was not only early, it was early and already changing fast inside. It may have gone through more than one round of star birth and star death in almost no time at all. That is the kind of detail that turns a record into a real problem. The clock is not just tight anymore. It starts to look brutally tight. There was another clue that pushed in the same direction. The color of the galaxy was not as blue as the youngest, cleanest systems could be. Some of its light appeared reddened by dust. Dust in space is made from heavier material too. So now the picture was not simply a first galaxy has appeared. The picture was closer to a young galaxy already looks older than it should. Before we move to the next break in the story, make one more call. What do you think comes next? A simpler explanation that saves the old timeline, or a new measurement that makes the puzzle worse? Write your bet below before we turn to the check that made this case even stronger. That next check came from the ground, not from Webb. Astronomers used ALMA, the Atacama Large Millimeter Submillimeter Array in Chile. ALMA studies much longer wavelengths of light than Webb sees best. It is powerful for tracing cold gas and certain glowing lines from atoms in very distant galaxies. In this case, it went hunting for oxygen, and ALMA found it. Not one vague hint, but a clear oxygen signal reported by two different teams in 2025. That is a major deal all by itself. It became the most distant detection of oxygen ever made, and because the line was so sharp, it also gave a very precise distance for the galaxy. Now you may notice something that sounds like a problem. Webb's first strong redshift answer was about 14.32. ALMA later pinned the galaxy near 14.18. That is not a contradiction that breaks the case. Both values place the galaxy at less than 300 million years after the Big Bang. The second result simply tightened the ruler and sharpened the picture. In fact, that sharper picture made the story harder, not easier. The ALMA work suggested the galaxy had about 10 times more heavy elements than expected for such an early time. Think about what that means. The universe had barely begun, yet this galaxy was already chemically maturing. It was acting less like a newborn and more like a teenager who somehow skipped several stages. One researcher compared the feeling to finding someone halfway grown where you expected only babies. That is a simple way to say it, but it lands hard. The galaxy was not just early in a calendar sense. It was early while already showing signs of fast inner history. That is why the oxygen result matters so much. It says the problem is not only distance, the problem is pace. Now put the pieces together slowly. First, the source was real, not just a messy blend. Second, it was extremely distant, confirmed by Webb and then tightened by ALMA. Third, it was bright, extended, and rich in signs of active stars. Fourth, it already contained heavy elements like oxygen. Each piece alone is striking. Together they form the reason this story would not stay quiet. So what kind of galaxy was Webb really looking at? Not a giant spiral like the Milky Way, nothing close to that. This object was likely clumpy and irregular, more like a rough early structure. But that does not save the old picture, because even a rough early structure should not have looked this built up, this bright, and this chemically advanced so soon. There is also a numbers problem hiding behind the light. A galaxy needs a dark matter halo, a gravity scaffold, to gather enough gas. Some scientists pointed out that JWST-GS-Z14-0 pushes close to what they thought could be the maximum halo mass available that early. That does not mean the laws of physics failed. It means the galaxy is pressing against the edge of what many models comfortably allowed. And there was one more reason people took this so seriously. The team did not search the whole sky to find it. They found it in a relatively small patch. If such a bright object appears in such a small survey area, what are the odds it is alone? That question hits hard because one weird object can be dismissed. A whole hidden population cannot be brushed away so easily. This is where the tone of the story changes. At first, the puzzle was about whether the claim was even true. Now the puzzle becomes something else. If the claim is true, how many more galaxies like this are out there? And if there are many, what exactly have we been getting wrong about the first few 100 million years? One possible answer is that early star formation was much more efficient than expected. In plain words, maybe gas was turning into stars faster than our models assumed. Maybe the first dark matter halos pulled matter together more quickly. Maybe the earliest stars were unusually massive, bright, and short-lived. If so, they would have made heavy elements fast and lit up young galaxies earlier than planned. Another possible answer is that our old surveys simply missed too much. Before Webb, we were trying to see the earliest universe with weaker eyes. Hubble changed astronomy, but it was not built for this exact job the way Webb was. So part of the shock may come from new vision, not a broken universe. Maybe the ancient cosmos was always busy, and we are only now finally seeing it properly. But there is a line we should not cross too fast. Some people hear stories like this and jump to, the Big Bang must be wrong. That sounds dramatic, but it is not where the real case points. JADES-GS-Z14-0 does not erase the age of the universe. It does not erase cosmic expansion. It does not throw out everything we know. Still, something important is under pressure. The part being squeezed is the timetable for building galaxies after the beginning. How fast did matter gather? How quickly did stars switch on? How soon did the first cycles of star birth and star death start filling space with heavier elements? Those are the parts this galaxy forces us to reopen. Here is the moment to pause and call it before the verdict gets sharper. Do you think this object means the rules of the universe are broken, or that our picture of early galaxy growth has simply been too slow? Leave your answer below, because the distinction matters more than the headline. The stronger reading is the second one. The broad story of the universe is not falling apart here. What is being challenged is our estimate of how fast complexity rose inside that young universe. Webb did not catch the cosmos cheating. Webb caught us being too conservative about how quickly the first galaxies could get to work. That matters beyond one record because early galaxies changed everything around them. As stars turned on, they flooded space with radiation. They helped clear the ancient cosmic fog and made the universe more transparent. If bright galaxies were common earlier than expected, then that whole chapter may have moved faster too. One object cannot solve that alone, but it points the flashlight in a new direction. JADES-GS-Z14-0 also matters because it is unusually luminous for its time. Brightness is not just a pretty detail. Brightness tells us how much intense activity was happening there. If the light is mostly from young stars, then a lot of stars were forming fast. And if a lot of stars were forming fast, then the first building phase of the cosmos may have been far more aggressive than many charts predicted. But the case is not closed in every detail. We still do not know exactly how common these objects are. We still do not know whether this galaxy is a rare overachiever or a sign of a large hidden crowd. We still do not know the full shape of its star formation history, and we still do not know which model change will explain all of its traits at once. That is why this discovery keeps breathing instead of turning into a dead fact. More Webb time will come. More ALMA follow-up will come. More distant candidates will rise, and some will fail while others survive. Even if the exact record gets broken, the deeper point exposed by this galaxy will not go away. Think back to how suspicious the source looked at first. Too bright, too close to another object, too strange to trust. In stories like this, that kind of opening often ends with a correction and a quiet apology. Here, it ended with the opposite. The weirdness survived the checking. And that survival is the heart of the whole case. If a claim looks wild and then falls apart under better measurement, that is normal science doing its job. But when a wild claim looks stronger after deeper imaging, longer spectra, and a second observatory checking its chemistry, the meaning changes. At that point, the burden shifts. Now the old expectations have to explain themselves. There is another subtle reason this story grips people. We are not just watching distance records move by small amounts. We are watching the border between too early to build much and apparently already building a lot get pushed. That border matters because everything after it depends on what happened before it. The later universe is built on the speed of these first steps, and those first steps may have been fast enough to feel almost uncomfortable. Within under 300 million years, matter had gathered, stars had formed. Some of those stars had already died. Oxygen was present. Dust may already have been affecting the light. That is a great deal of history folded into a very short slice of cosmic time. Before the next turn, I want your prediction on the hardest part. When we finally walk back to the opening claim, do you think the right verdict is yes, no, or yes with a catch? Put that choice in the comments right now because the catch is where this whole story lives. The verdict is yes with a very important catch. Yes, Webb found a real galaxy from less than 300 million years after the Big Bang. That part holds up. The distance case survived. The galaxy case survived. The oxygen result made the timeline feel even more real, not less. But the catch is that Webb did not find a simple primitive speck. It found something that already looked more developed than many people were ready for. Not old in the sense of a calm modern galaxy, not mature in every way, but mature enough, bright enough, and chemically enriched enough to force a rethink about speed. There's a second catch too, and it is just as important. The opening line says Webb found it, and that is true. But Webb alone did not finish the argument. Webb discovered and strongly confirmed the galaxy. ALMA later sharpened the distance and nailed down the oxygen. So the real answer is bigger than one telescope. It is a joint case built by different tools seeing different kinds of light. That matters because science is strongest when separate checks point the same way. An image can mislead. One spectrum can leave room for doubt. But when deep imaging, long spectroscopy, and a different observatory all lean toward the same story, confidence rises for the right reasons. That is why this galaxy moved from shocking claim to serious cosmic clue. So the opening statement was not false, it was just incomplete. Webb found a galaxy from the universe's first 300 million years. What makes that statement truly explosive is not only the age, it is the fact that this galaxy already seems to have lived through more internal change than the old picture expected by that age. That is the part worth carrying forward. The early universe may have started organizing itself faster than we imagined. The first bright systems may have switched on sooner. Heavy elements, the raw material later tied to planets and life, may have begun spreading earlier too. We are not talking about life in this galaxy. We are talking about the speed with which the universe started making the ingredients that later matter to everything, and that reaches all the way to us. Every atom of oxygen you breathe was forged inside stars. Every heavy element in your body came from cosmic history that unfolded step by step over time. So when we learn that galaxies were making and spreading those elements earlier than expected, it changes our sense of how quickly the universe became capable of complexity. That is not a small emotional shift. It is a new timing for our own deeper origin story. It also tells us something about human curiosity. We build machines, send them far from Earth, and point them into darkness so deep it feels almost impossible. Then a tiny red mark appears, and suddenly our neat timeline has to answer for itself. That is one of the best things science can do, not give us comfort, but give us a clearer surprise. So if you came in wondering whether this was just another loud headline built on a faint blur, here is the clean answer. No, it was not just hype. The object held up, the challenge held up, and the later oxygen result made the challenge sharper. The case did not get weaker with time, it got stronger and stranger. What happens next may matter even more than the first announcement. If Webb and ALMA keep finding more galaxies like this, the pressure on early galaxy models will keep rising. If Jade's GSZ 14-0 stays rare, then we will need to explain why this one raced ahead so quickly. Either way, the old easy picture is gone. The first few 100 million years now look less quiet and much more alive. That is why this discovery keeps pulling people back. It is not only about the farthest or the earliest. Records come and go. What lasts is the deeper question the record opened. How fast can a young universe make structure, light, dust, oxygen, and the first real complexity? JADES-GS-Z14-0 forced that question into the open. So here's my final verdict. Webb really did uncover a galaxy from the universe's first 300 million years, and that claim survives scrutiny. But the true shock is not the date alone. The true shock is that the galaxy seems too capable, too bright, and too chemically advanced for how little time had passed. That is why this is not just a discovery, it is a warning to our old timeline. If you want the deeper story, not the shallow headline, subscribe and turn on notifications for the next one. Then tell me in the comments which idea you find more convincing. Faster star formation, better instruments, or something we still have not thought of. And share this with someone who loves space mysteries, because this is the kind of clue that gets bigger the longer you sit with it. Thanks for staying with me all the way to the end.